Hey all! So usually I get things right, but sometimes I might get things wrong, and this might be one of them. You've all seen this before, and it's back with the same fault. However, we don't know what's causing it. We can likely guess what's causing it, but whether or not it's the same parts I replaced as last time, that remains to be seen. But yeah, if it is, then I guess the previous parts were not a perfect match for the system, but if not, I'm thinking this thing's probably fairly stressed, and you'll find the other parts are dying off one by one, but we'll pull it apart and find out for sure. Now, if you recall, last time we replaced these two power transistors on that channel, and what we need to do now, since it blew all the fuses, is safely assume that one of the channels has again shorted, and I'm going to get my multimeter into, I always use diode check, and see what we can find. So I'll show you what I've got here. If we go base to emitter on here, and we've got half. And again here, because this is our NPN, then we've got half again. Half a volt drop there. And then as we should, there, it's all looking grand. Of course, these ones are PNPs, these other three, but I mean they're all connected in parallel, so a short on one would drop the whole lot down and appear to be all dead. So that side being okay, what I'll do now is spin it around. We have exactly the same on the other side. And we'll shoot up this side. And what do we get? Oh yeah, look at that. Well, they're alright. They're our NPNs up this end, I believe. The heatsink's on, I can't see the numbers, but that doesn't matter because we don't have a short on the channels there. So we must ask ourselves, why did the fuses blow? Possibly a power supply issue. Which is where I started looking last time, if you recall, because of a red herring and being stupid when I was connecting up the power and forgetting where the fuses went and such, and going the wrong side. But here's the fuse. Fuse is coming through here, and if we get our meter again and trace through which side of the fuse the B plus line comes on, we have B plus on here and nothing there. There we are. So don't know if you can see that there, but I'll zoom in, and down in the bottom here we've got one connection for this fuse, and then the other comes in over here. The fuse mounts vertically. It's a standard automotive blade fuse, and then I've got, of course, 3 rows of that. They're all parallel together. So since the B plus comes in and goes through to the bottom one, then our circuit without the fuses in, because they're all blowing, is the top one. And what I want to do is first of all take a resistance measurement to ground and see if there's excessively low resistance on ground there. And here we go, ground, and the B plus line straight after the fuse. And as you can see, there's a dead short circuit, 0 ohms, which is definitely going to blow our fuses. Now I don't know, it's quite interesting because he said it was running fine. It was running at low volume. So yeah, this shall be interesting. I think probably what's happened is switching FETs here have shorted for some reason. The base drive resistors aren't charcoal, which usually happens when they go, is from my experience at least. So we will trace this through and see what we can find. Okie dokie, so what we're going to do is run up this side first, and we've got our gate, drain and source in that order all the way along here. So we'll chuck our positive on the gate and check gate to drain, gate to source. We've got a reasonable 0.3 volt drop there, that's alright. Same on that one, same on that one, same on, oh, not same on that one. Okay, so we've found one where the gate to drain is shorted, and there's another one, gate to drain, gate to source shorted, and there's a third one. So we've got three. These three here appear to be shorted, and since they switch directly across the they switch the battery directly across this transformer. When they go shorted, they have they create a direct short through to ground, because when they're on, power goes through the primary winding of the transformer and through the switching FETs out to ground for the brief period that they're on, because they're turning off and on really quickly. And of course, when this shorts, the winding resistance is so low anyway that when they're turned hard on, you get maximum current flow. Well, sorry, not turned hard on. When they're shorted, it's like being turned hard on, so to speak, and you get maximum current flow through these to ground, and takes out your fuses. Because these would probably, I don't know what sort of duty cycle they switch them at, but they wouldn't be running really anywhere near full on at any for more than milliseconds, I guess. So we could scope that once it's going, just out of curiosity, and you can see how quickly they're switching the gate on these. That might be interesting to look at. But yeah, so three there that have shorted, which is interesting to say the least. I think this amp's getting tired. I don't think it would have been anything he did while running it. But yeah, over here we'll do the whole process again. Gate to drain, gate to source. Not really the best setup I have here, is it? Gate to drain, gate to source. And so on, and so on, and so on, and so on, and so on. And yeah, they all look good. Oh, that's good. Not so much to worry about there. Right, I've got the three out. They're definitely shorted. Interestingly, where the PCB trace meets the or goes to the leg of the drain leg of two of them, the PCB, the trace has actually got a crack through it, it's actually melted the track slightly and torn it up, and that's a fair whack of current. I mean, when you've got three 25 amp fuses in parallel, you're getting well, I suppose 75 amps possible. Ugh, I think it blew them all. I don't think they'd blow in sort of, well, I'm sure they have all different slightly different rates of blowing, but Okay, point is there would have been a fair bit of current going through those traces, but here I have the guts of a 12 volt to 240 volt inverter. This one was either in a very bad place, or it has very, very cheap recycled components in it. So many legs on transistors and diodes and whatnot are rusty. Suffice to say, this thing didn't last very long at all, and I don't even think it was that old, but it does have IRF 740 FETs in it. Now they are slightly under the rating of what's in this amp at the moment. This amp currently has a DFP50N06. Now they are you know, continuous current and pulse current wise, they're a few amps higher, but I don't think we're going to exceed the IRF 740's rating, especially when there's 3 in parallel to handle the load. And yeah, so it should be well within the spec while it's running, and especially if he doesn't run it that loud. I don't think he likes to have it blasting its ass off, but and being on a budget, what I'm going to do is just throw these in. They test okay. Can't go wrong with scrap parts, really. I mean, they're either going to work or they're going to fail a little bit later on. At least it hasn't cost anything, and that's the main thing. So we'll throw those in and make sure this thing will fire up again. Right, now I've got these out, and they had their own little sill pad on them, very sticky on one side where it goes onto the FET side. So I'm just going to clean off that glue first, a little bit of electronic cleaner, because I want the best connection thermally through the sill pads that are already in here. I don't want anything to get in the way of removing heat from these things, because that will certainly be the death of them in no short amount of time. I'm not even sure why they have glue on them for a start, unless they're cheap and nasty or something. I don't know. It could be alright, it could be normal, but maybe they're an anti-vibration sill pad, maybe. Extra stickiness to prevent against loss of contact. But I don't think it's worth taking the chance leaving it on there, especially when it's a freebie. You want it to try and last as long as possible. Alright, that looks pretty clean. So we'll get them mounted now. As far as the pin length, I can compare it to an old one, I guess. So we've got an old one on the left. I just need to, oh yeah, those pins are almost bent in the right position. Just give them a bit more of an angle each. And if you've got pliers that are tapered like mine, and you see how they taper off, when you put legs into bend, you don't want to go straight across like that, because as you'll see, you'll get the top leg will be longer and at a different angle than the bottom leg. So you just need to make sure that you straighten it up as far as so it's in parallel with the edge of the angle of the pliers, and then you get a nice even bend on all 3 pins there. And then they should fall off my hand and go under the board. And line up with the holes thereabouts. There's one. The glue there still. the other one. One of these was the old one, you dumbass. That one. Don't want to put an old one back in. She'll be all over. Line those back up. Get that over. Close enough. Sometimes you get a bit of solder left on the end of the leg. It won't go through the hole. That's all good. Just straighten that up a bit more. And the one with a bit of extra solder, wipe that off. Right, so then what I do, just because they're all sort of hanging at different angles down there, is I'll just tack one leg and put a bit of solder on that, and then I'll hold the hold the thing in position while I reflow that leg, just so that it sort of sits closer to the angle it's going to sit at when it's mounted in there, so that I'm not soldering the legs and then bending it into position, and that way there's a little less strain on the leg, and it's my theory that it might minimize long-term solder joints cracking, due to the fact that these things get quite warm, and so there's a lot of thermal expansion and contraction, and I'll put a lot more solder on there because I need to bridge the gap in the trace where it broke or melted the trace. So once again, and this one too had a melted trace in the middle here, so just make a nice solder bridge. Okay, now with everything somewhat together, we can test between ground and positive for resistance again, and I can tell you we're looking at a climbing increase, start about 300 ohms and is going up into the K ohms, which is what we expect because these capacitors are charging. So there's no longer a short on the B plus rail, so what I will do now is connect power, and if you remember, we have our little everything is good light. So it goes from red initially, it should change to green if everything is okay. Listen for the explosions. Well, that tripped the protection on my power supply. That's not good. Let's just see what's happened there. If we do another, first I'll just check voltage on the input there. No, and our resistance reading is still high, so it hasn't. Yeah, so for whatever reason, it's drawing a bit of excess current there. Let's check those FETs and make sure they haven't gone and sabotaged themselves. Still giving us a reading. Wait, wrong side. Try again. Take two. They're alright. They're alright. Maybe it was just the initial kick that my power supply wasn't expecting. Right. Okay, I'm going to attempt to see a waveform on the gate of one of the drives, and I've got a current limited to 600 milliamps. It may or may not work. I really don't want to get these FETs too hot if all they're doing is being switched on. Of course, in order to current limit, the voltage is going to drop, and that might cause the IC to drop out and not provide a signal. So yeah, it probably won't work in my favor at this stage, but we can always crank the current up and see what happens, at least briefly. So as you saw, not a lot. The FETs aren't getting hot, which is interesting. There's although there's only 7 volts at half an amp. There's a bit of a signal there, but I'd expect a whole lot more. It's just a bit fuzzy, and I'd also expect it to be a bit more than 100 millivolts. Okay, let's crank this up and see what it allows me to do. No, it's still at 3 amps. It's dropping right down. It's not giving me any signal. I'm probably going to have to switch to the other power supply that does allow 10 amps worth, albeit very briefly. Okay, so I'm now forcing 12 volts into it. It doesn't stay on long. I've got a 10 amp cutout on the power supply. It just cuts it all together. But while it is on, and if I tap the remote wire on so you can see it briefly without supply cutting out, you will see that we do have solid gate drive to one of the banks. So there we go, and it cut out, but that was half a volt to the gate, and it was yeah, on constantly. Now half a volt doesn't sound like much really. I would have thought it would be bigger than that, but the fact that it doesn't start oscillating may point to a faulty chip. I might have to do a bit more research on this. Okay, what I've done is I've just quickly lifted the sync pins on each of the FETs, so as you can see it's lifted up there. That way when the FET turns on it cannot pass current, and I thought about lifting the gate drive resistor, but that would leave the FET floating and possibly just randomly turn on as they do when they if they form a charge across the gate from somewhere. So not ideal. So I've left that on, left the gate tied on, and just removed the sync pins, and we'll see what happens there. So now we'll see what happens when I turn it on with the sync pins lifted, and hopefully she won't pull a lot of current, and it's not. So that's on, and that's supposed to be a gate drive signal, and certainly higher. We're at 1 volt now instead of sorry, that's 1 volt there, half a volt per division. So if we have a look over at the IC, pins 9 and 10 are our drive pins. That's pins 9, and there's pin 10. It's got some kind of pulse coming out of it now. It didn't have that before. Isn't that pretty? So that's oscillating, and that one's just sitting high, which is tying, well, it's turning the gates hard on. See, we've got it's a 1 volt peak square wave there, and just a solid output from there, which is what our problem is. I'm going to say that this drive IC has probably failed, and it's a bit unfortunate. I'm not entirely sure where I might find another one as yet. Do a bit of research and see what I can dig up. Okay, I've got a replacement IC installed. Just happened to have one lying around, and I was using it to control a plasma speaker, where you create a high voltage plasma arc and modulate it with audio so that you're getting audio off the spark, and it is really cool. If you get the chance to make one, I highly recommend it. Just something fun to do. I was able to find this IC in a it was a power supply. I think it was a computer power supply actually. It's a very commonly used pulse width modulation control IC. But anyway, let's connect this up and see if I was right or if I'm completely off track. And I've just got the scope lead tangled around the camera. So remember, we were looking at pin 9 and 10, and pin 10 had the proper modulated square wave coming off it, and 9 was solid, so I'm just going to connect up power now. And what have we got? There we go. Now, as you can see, interestingly, it started off as nothing and then popped on the screen and got a little bigger as it's trying to find a suitable oscillation to create a voltage that's not there, because the FETs aren't operating, so there's no secondary voltage to compare with. And if that was pin 10, if we look at pin 9, look at that, pin 9 now has a output wave. So the IC was definitely faulty, it seems, and when I connect that, it should be go all over the place. Or something will explode. I don't think it'll be that bad. There's no other indication I can see that something else is faulty with this unit, so let's solder those FETs back up and see what happens. Right, everything's back in position, and if we're watching our lights here, I'm just going to switch her on and cross fingers. 3, 2, 1. And there's our red light and our green light, and she's idling away at an amp there. Excellent. I will throw it back into the case and give it the old test with a speaker on it. Get a bit of load going. I might just run this for a bit longer instead of saying that's it and giving it back to him. Yeah, we'll give it a bit of a stress test here if I can, and see what we can come up with. I think his installation could be a bit dodgy as far as the leads to the battery and whatnot, and as ground. A little quick theory behind what happened here. If the wiring isn't too crash hot and he's not getting sort of, when the engine's running, you're getting 13.8 to 14.4 volts off the alternator, and if the wiring's not too hot and she's floating around sort of 9 or 10 volts, for example, what's going to happen is, in order to achieve the output voltage of, I don't think I measured this, I'm going to say it's going to be about 40 odd volts on the secondary side here. To achieve that, this has to switch a lot harder and work things a bit harder. And then as the voltage comes up, it won't need to try as hard. It can lower the switching frequency, and it'll be a less current draw, but certainly if it has to switch harder because of a lower voltage, if it's a bad connection or for whatever reason you get an increase in voltage back to what it should be, you're going to get a surge in current through the system, because it's switching to compensate for that. So it's more on, these FETs are more turned on because of the lower voltage. So when the higher voltage comes rushing through here, because of that, the extra stress on parts. I don't know why that IC failed, because I would have expected a blown FET to take out the transistors on the way, but I guess stranger things have happened. We'll check his installation out as a next step and make sure everything's kosher there. Alrighty, good as gold. Yeah, seems to be running and doing the business. So yeah, I don't know, I still think we need to check out his installation, of course, but I'm going to call that fixed for now, and thanks for watching.